So the lesson for today is lesson 2-2 and its applications of proportions. We've been doing proportions and now we're basically just going to apply those to different objects and situations in the real world. Your vocabulary, the first word, the words are in red as they come up, and the first word is called similar, and it's just two shapes that have exactly the same shape but not exactly the same size. So an example here is triangle RST is similar to triangle BCD. Triangle RST is similar to triangle BCD. And so similar figures have what we say as corresponding sides and angles. Sides and angles, and which are the same relative position. So the corresponding angles here is angle R and angle B. Another corresponding angle would be angle T and angle D. The third corresponding angle would be angle S and angle C. Also the sides correspond. So in particular, we have 8 feet here corresponds with X. 5 feet here corresponds with 12. And then the missing side, we'll call it side Y, corresponds with side Z. So those are all corresponding sides and corresponding angles. Your next vocabulary word is called scale factor. And that's when we have a shape. Take, for example, the shape B here. Shape B. It has one side is 6 inches and the other side is 3 inches. And what we do is we multiply by a scale factor. So we multiply by, let's say, 3. If we multiply both sides by 3, we would have a side length of 18 inches here and 9 inches here. So all we did was we created a corresponding or a similar figure. So this side corresponds to this side, and this side, 3 inches, corresponds to 9 inches. And all that we did was multiply by what we call a scale factor in the middle. A helpful hint on what a scale factor is written here. If a scale factor is greater than 1, it's going to make the image bigger. If it's less than 1, it's going to make the image smaller. Our last vocabulary term is one that we've been doing, but it's just a different way of stating it, and it's called unit analysis or dimensional analysis. And that's just a process that uses rates to convert measurements from one unit to the other. A simple way of saying this word is by just using the word converting. Converting. In science, though, you will use the word dimensional analysis often. 2 short examples for applying proportions. The first example is using these similar figures, triangle ABC and triangle DEF. The example states that triangle ABC is similar to DEF, so we're going to create a proportion in order to solve for the missing value X. So I can see by looking at the 2 triangles that 5 is corresponding with 4. And 7 would be corresponding with X. So I'm going to set my proportions up in such a way. I'm going to say 4 corresponds with 5 the same way that X corresponds with 7. As you can see, the bottom is represented by the triangle ABC, and the top is represented by triangle DEF. And then I can simply solve that proportion and get the answer. So I cross multiply. 4 times 7 is 28. 5 times X is 5X. And then I divide both sides by 5. So my answer here will be that X is equal to 28 over 5. That is about 5.6. So the missing side here would be 5.6. Okay, example number 2. Roger, it says Roger is 5 feet tall and casts a shadow 3.5 feet long. At the same time, the flagpole outside the school casts a shadow of 14 feet. So Roger's height, this is Roger, and it's saying that he is 5 feet tall. 5 feet tall. And his shadow is 3.5 feet. And then we have a pole flagpole that is X feet tall, we don't know it, and its shadow is 14 feet long. And so we're going to use a proportion. I know that these are proportional. They're similar figures, okay? So I'm going to use a proportion and say that Roger's height is proportional to the flagpole's height. So I say 5 feet is equivalent to X feet for the height of the flagpole versus the height of the shadow, which is 3.5 feet, so 14 feet. Okay? So we set up the proportion, and we cross multiply and divide to get the answer. So cross multiplying, we get 5 times 14 is 70. I get that 70 is equal to 3.5x. And then I divide both sides by 3.5, and I get that x is equal to 20 feet. So my flagpole is 20 feet. I want to make sure that's reasonable, and it is, okay? 20 feet is a good height for a flagpole, okay? So there are different ways to set up this proportion that are still correct. So you may have done a different way, but it would still be correct.